This is section 2.7, inverse functions, part 2. So picking back up with finding the inverse functions, it gives us the function 2x plus 5. So first let's do it by hand. So this is f of x equals 2x plus 5. Then remember that I'm going to replace my f of x with y. So I have y equals 2x plus 5. Then I'll switch my x and my y. So that's the really big part, or like the big identifier of inverse functions, is that when you're finding the inverse of a function, you'll see that the x's and the y's are switched. So we do the same thing when we're doing that in the equation. Okay? Then I'm going to solve for y. Divide both sides by 2 to isolate that y. And I'm actually going to write my y on the left side. Okay, and then the very last step is to replace that y with the inverse of f of x. Okay, so that's doing it by hand. I see that this is my original function and this is my inverse function. Okay, so now let's go ahead and graph them. So we get into our graph, we're going to do 2x plus 5. Execute to go to that next row, and we have a fraction, and then x minus 5. And I say this a lot in the videos, but it's just a common mistake. I've even done it even after I know to not do it. But when you're saying x minus 5, make sure that you use this symbol right here above execute. And then if you're trying to notate a negative value, you would use this right here to the left of execute. It's just caused problems before when we're trying to graph. So if you have any issues, see if maybe you actually did. Also, when you're trying to get your x, make sure that you use this button right underneath alpha. Okay. Oops, I added an extra x. There we go. Okay, let's go ahead and draw it. And it doesn't, remember that depending on the dimensions of your window, it might seem a little skewed. But if we were to draw a diagonal line down here through the origin, these two graphs would be complete reflections of each other over that diagonal line. So every x on this one right here is a y on this one right here. And every y value on this graph right here up top is an x value on that bottom graph. And here we can see it on the calculator. That actually shows it in 2 different colors, a little snapshot there. So we do domain. The domain of the original function was negative infinity to infinity. And then the range was negative infinity to infinity. So this is not the greatest of examples because the domain on the inverse is negative infinity to infinity, and then the range on the inverse is negative infinity to infinity. And the reason I say this is not the greatest of examples is because what we'd like you to see is that the range of the original function will be the domain of the inverse. And the domain of the original function will be the range of the inverse, that's true to this one, but since the domain and range were the same, it's a little hard to actually see that, but we'll see that in these ones coming up. Okay, they want us to find the inverse function. So remember, our first step is we need an x and a y to switch. So change that f of x to y. Then go ahead and switch the x and the y. Then solve for y. So I'm going to multiply both sides by 7 to get rid of that 7. Divide both sides by 3. And we get, I'm going to flip sides, y equals 7x plus 2 over 3. Last step is to change that y to inverse of f of x. And that is our inverse function. I think the biggest part of this one, again, is knowing that you have to switch that x and that y and then solve for y. Okay, so let's talk about the inverse operation of cubing a number or squaring a number. Or finding the cube root or the square root of numbers. So the cube root of 125 is 5, right? Because 5 times 5 times 5, so 5 to the third power is 125. So those would be inverse functions, finding the root to something or raising it to a power. Those are inverse operations, as is addition and subtraction or multiplication or division. So when we go to write the inverse function, if we want to undo something that's being raised to a certain power, then we're going to find the root of that same value. It's called the index. When it's whatever this value is, we'll find the root to that of that same index. And if something is being raised to a certain power, then or vice versa, if we're finding the root of something, like in the second example over here, then we would raise it to that same power to undo it. So notice that this originally was cube root of x, and then we raised it to the third power. That x dropped out and it was just x now, because these are inverse functions. Same thing over here, we had x cubed and we did cube root of x, and so we're just left with x. Okay, so that's going to be something we need. So keep that in mind, that those are inverse operations of each other when you're raising something to a certain power or finding the root of that number. Okay, the function of f of x equals x cubed minus 7, and it is a 1-to-1. So that's their way of telling us, look, there is an inverse function to this. So they tell us to go ahead and find the equation for the inverse of f of x, the inverse function. All right, so let's write the function down first. F of x equals x cubed minus 7. Our very first step is to replace f of x with y. Our next step is to switch x and y. Our next step is to solve for y. So here we go. I have y cubed, y raised up to the third power. So I need to undo that because I don't want y raised up to the third power. I just want y. So cube root, And then on the other side, I have to do it to the entire side, cube root. So y drops out, and then I have cube root of x plus 7. One of the most common mistakes that we see is that students will not put the plus 7 underneath the radical. So they will not house it together with the cube root of x. And the reason that it's underneath the radical, the little house, is because, oh, let me flip it. I meant to flip it. Is because it happened, the 7 was already on that side. X plus 7 was completely on that side. And then we found the cube root of that side. So everything on that side will be underneath the bar of this radical symbol. Okay, be careful of that. That's probably one of the most common questions we hear is, well, how do I know when it's going to be underneath the radical? Well, it depends. What happened first? When you're undoing these operations to isolate y, what happens first? And I think we'll see an example of when it happens afterwards. But let's say that I went ahead and did the cube root of x plus 7, but then it wasn't just y over here. It was y minus 2, right? So we got rid of that, raised up to the third power, but then even when I got rid of it, I still had minus 2. Well, now when I would add 2 to both sides, that would not be underneath the radical, right? Because that radical is already on that side. So anything I do after that goes outside the radical. Okay, we still need to finish off because we still need to write inverse of f of x. And now we're finished. Hopefully that made sense. I sort of felt like I went in circles a little bit there, but it's just such a common mistake. And even during the exams, that's one of the things we see is that students will put a value that's not supposed to be underneath the radical under the radical, and then if it was supposed to be there, they'll put it on the outside. Okay, this is a perfect example. So that one, we saw that it went underneath the radical. Let me see. I think we might see it in this one. All right, let's see. Replace f of x with y. Okay. Then switch x and y. Solve for y. So I want to get y from out underneath the radical, right? I can't touch anything underneath that radical until I get rid of the radical. So I'm going to take that entire side and raise it up to the third power. Do the same thing on the other side. That will drop out y plus 5. And then I can subtract 5. So this is not giving you an example of what number to go underneath the radical, but notice that x cubed is separate, right? So it doesn't look like this. I'm going to give you an example of what it doesn't look like. That minus 5 would have already had to be on the side with the x before I cubed both sides for it to look like this. But it was not, right? And because it was not, then it happens outside of the x cubed. So just keep that in mind when you are undoing these, whatever the operation is, just make sure that you're truly following suit with that one. Okay, so I'm going to flip this. Y equals x cubed minus 5. Our very last step is to change that y into inverse of f of x. And this is our inverse function. Okay, so these are a little bit different. Instead of giving you a function, they give you a table of values, right? So x, basically the inputs and the outputs. And they want us to find the inverse of g of 10, okay? Well, look at it. Excuse me, the inverse of f of g of 10. I left the f out. So look at it though. They don't give me a table of values that has the inverse of f, right? They just give me a table of values for just the function of f and the function of g, okay? So I would actually have to set up the table, and I recommend doing that first, the table of the function of the inverse of f. Well, remember we said that what happens with the inverse? Just the x's and the y's are switched. So if I made my table for inverse of f, then these would just be switched. Now, you don't have to make a separate table. You can just go say, oh yeah, it's switched, and try to find it that way. But I find that students get a little confused with that, or will get lost in the numbers with that. Okay, so now that we have that table, we won't need that one anymore. So we'll start from the inside. So what is g of 10 equivalent to? Well, let's go to the table for g of x. And we see that, right? When x is 10, my output is 4. So g of 10 is equivalent to 4. Okay, so then on our table for our inverse of f, when our input is 4, what is our output? 0. So this would be equivalent to 0. So once you get your table set up for your inverse, if you have that scenario going on, then you say, okay, let me go ahead and start from the inside, replace that inside value, what's g of 10, and then, okay, now what's the inverse of f of whatever the value may be. In this case, it was 4. And then the output was 0. Let's try another one. Okay, they want us to find the inverse of f of g of 9. Again, they don't give me a table for the inverse of f of x. They only give me a table of f of x and g of x. So I'm going to go ahead and make the table for the inverse of f of x. Remember that these just get switched around, so I just go down the line for my x's over there. All I did was copy these x's down for my output, my y, and then I copy these for my x's. Okay, don't need that anymore. Now I gotta figure out what g of 9 is. When x is 9, my output is -1, so g of 9 is -1. And then on my inverse of f of x table, when my input is -1, my x is -1, my output is 3. So this would be equivalent to 3. It's simple in a way, but it can also be a little tricky. So I would just say take your time. Draw on the paper. I don't just draw arrows to show you guys. I draw arrows because it helps me keep my eyes on the number I actually have to, look at and what the actual output is. So definitely draw it out if you can. Okay? On this one, it says the functions f and g are defined by the following tables. Use the tables to evaluate the given composite function. So they want us to find g of f of -1. So I'm going to rewrite this. Notice that there's no inverses, right? So I don't have to do an inverse table. But they do want me to find g of f of -1. So I'm first going to find f of -1. So if I go to my f of x table, f of -1 equals 3. So really they're asking me find g of 3. And on my g of x table, when my input is 3, my output is -2. So that would be my answer.